Something unprecedented is happening right now. In September 2025, Earth is facing a wave of near misses. Asteroid 2025 FA22 will slip past us at just over twice the distance to the Moon, while 2025 AJ2 surges even closer, less than 300,000 kilometers away. Dozens of smaller objects are being logged at sublunar distances in a single record-shattering week. At the same time, 3ITLAS, a chemically bizarre interstellar visitor, is accelerating toward Mars on a trajectory unlike anything in the Minor Planet Center's archives. The numbers defy probability. Is this just cosmic coincidence, or are we witnessing a pattern that could rewrite how we defend our planet? The answer may change what it means to be a bystander in the solar system. September 2025 arrives with an unbroken string of alerts. Astronomers at the Minor Planet Center log asteroid 2025 FA22 at just over 2.2 times the distance to the Moon, about 835,000 kilometers. 3 days earlier, 2025 AJ2 slipped by even closer, a mere 0.78 lunar distances, or less than 300,000 kilometers. These aren't isolated events. The week of September 12th to 18th shatters all previous records. At least 28 near-Earth objects pass within the Moon's orbit. That's triple the prior weekly high. Most are small, in the 8 to 25 meter range, the kind that could vanish in the atmosphere or explode like Chelyabinsk. But 2 FA22 and RJ2 are large enough to demand global attention, with estimated diameters up to 120 meters. Each detection flashes across the screens of survey teams. Pan-STARRS in Hawaii, Atlas in Chile, the Rubin Observatory in Chile's Atacama Desert, Catalina in Arizona. Data streams in from automated telescopes, processed by software tuned to catch even the faintest, fastest-moving blips. The pace is relentless. New objects are flagged, tracked, and logged, sometimes within hours of discovery. The Rubin Observatory, only months into full operation, contributes a flood of fresh data. Its wide-field camera covers the sky in sweeping arcs, picking up objects that would have slipped by unnoticed just a year before. Statistically, this is supposed to be a once-in-decades event. Some experts speculate about orbital resonances or a hidden breakup event in the asteroid belt, but the majority point to the power of new technology. Detection efficiency now exceeds 90% for objects larger than 20 meters within 1 lunar distance. Blind spots are shrinking, but they're not gone. Sunward approaches remain a weakness, a lesson seared into memory by the Chelyabinsk airburst 12 years earlier. On social media, the numbers fuel speculation. Charts circulate showing a spike that looks too sharp to be chance. Orchestrated, some call it. A warning shot, others suggest. In scientific circles, the mood is more measured, but no less alert. Each close pass is logged, analyzed, and archived, feeding into a planetary defense system that is only as strong as its latest detection. For a brief window, the world's attention flickers to the sky. And the question lingers. What if just one of these objects had been aimed a little closer? Imagine FA22 hadn't missed. At 120 meters across, roughly the height of a city block, the asteroid's entry would begin high above the atmosphere, a silent speck hurtling at over 18 kilometers per second. If it were stony like most objects of its size, it would compress the air ahead until the pressure shattered it in a violent airburst, much like Chelyabinsk in 2013. But scale matters. The Chelyabinsk shockwave broke windows across 6 cities and sent more than 1,500 people to hospitals, mostly with glass cuts and concussions. FA22 carries more than 20 times the energy. A stony asteroid this size could explode at an altitude of 10 to 20 kilometers, releasing energy equivalent to several megatons of TNT. The shockwave would flatten buildings across dozens of square kilometers. Anyone caught near the blast center would have seconds, if that, to react. Glass would shatter, walls would buckle, and the heat flash could ignite rooftops. The devastation would not be limited to the point of entry. Outlying neighborhoods would feel the blast, with flying debris and collapsing structures multiplying the danger. If FA22 were made of iron, the story changes. Iron asteroids are denser, more cohesive. Instead of fragmenting, an iron body could punch straight through the atmosphere, striking the ground at nearly full speed. The result? A crater hundreds of meters wide, a fireball visible for miles, and a plume of ejecta lofted into the stratosphere. The local impact would devastate infrastructure, but the environmental ripple could reach far wider, depending on location. Now shift the target to the ocean. Over 2/3 of potential impact sites are water. Here, the energy transfers into a massive steam plume and a series of tsunamis radiating outward. While most of the wave's energy dissipates quickly in deep water, coastal regions within a few hundred kilometers could see walls of water tens of meters high. Ports, cities, and low-lying islands would face catastrophic flooding with little warning. The Chelyabinsk event exposed the blind spot, objects approaching from the sunward direction, invisible to ground-based telescopes until the last moment. Sergei Karpov, whose dashcam footage became an icon of that morning, still describes the aftermath in terms of noise, glass, and confusion. Years later, he works with disaster response teams, urging cities to rehearse for events that give no warning. His message is simple. The line between a harmless fireball and a city-leveling disaster is thinner than most people realize. In the simulations run after each close pass, the numbers are stark. Impact energy, population density, time of day, all variables in a cosmic equation that plays out without malice or intent. The only defense is vigilance, early detection, and the systems that turn warnings into action. Without them, the cost is measured in shattered cities and lives forever changed. Then there's Comet Swan, a different kind of spectacle. Discovered on September 11, 2025, not by an optical telescope, but by the Solar Wind Anisotropies instrument aboard SOHO. This comet's arrival was announced by a sudden surge in hydrogen emissions. The Lyman alpha glow, an ultraviolet fingerprint invisible to the naked eye, lit up the data streams before most ground-based observers even knew to look. A handful of backyard observers scanning the Virgo constellation confirmed what the satellites had hinted. SWAN was brightening fast, its tail doubling in length over a single night. This wasn't just a matter of brightness. This was something else. The sky is full of wonders and warnings. The events of September 2025 are a powerful reminder that our place in the cosmos is dynamic and, at times, precarious. It highlights the incredible progress we've made in watching the skies, but also how much is left to learn. Have you ever looked up at the night sky and wondered what secrets are hiding in the dark? Well, sometimes those secrets come hurtling toward us and they have incredible stories to tell. Today, we're diving into 3 amazing celestial events that are keeping astronomers on the edge of their seats. From a comet that's literally falling apart to a dress rehearsal for saving the planet. First up, let's talk about Comet Swan. When this cosmic snowball started getting close to the sun, it put on a show that caught even seasoned comet watchers off guard. Imagine a chunk of ice, but instead of just melting, it's exploding with hydrogen gas. Spectroscopy revealed its coma was packed with hydrogen, along with a sprinkle of other compounds. As it got hotter, the amount of gas spewing out went through the roof. The reason? SWAN's icy core was cracking under the sun's intense heat. Each new fissure exposed fresh layers of frozen gas, releasing it in a series of dramatic outbursts. It was like a cosmic firework display, but one you could only see with special ultraviolet instruments. Professional observatories like the Rubin Observatory had to shuffle their schedules to get a closer look at this evolving spectacle. But here's the cool part. They weren't alone. A global network of citizen scientists played a crucial role. These dedicated amateurs with their backyard telescopes were feeding data to the pros, timing the outbursts, mapping the comet's tail, and flagging any sudden changes in brightness. Their alerts helped guide powerful spectrographs to catch fleeting details, jets of material, shooting from the core, and subtle shifts in its chemical makeup. These were the telltale signs that Swan was under serious stress. As September approached, the big question was whether it would survive its closest pass by the sun. Models suggested its fractured nucleus might completely break apart, creating a spectacular debris cloud visible from Earth. For planetary defense teams, Swan was a powerful reminder that not all threats are quiet and predictable. Sometimes the first warning shot is a sudden burst of hydrogen, spotted by an amateur astronomer staring at the stars. Now let's shift from a fragmenting comet to an asteroid that once made doomsday headlines, Apophis. Mark your calendars for April 13, 2029. On that day, Apophis will make a breathtakingly close pass by Earth, coming within just 32,000 kilometers of our surface. That's closer than many of our own satellites. It will be so close, you will be able to see it with the naked eye as a star-like point of light gliding across the sky. When Apophis was first discovered back in 2004, It was flagged as a potential planet killer, and for a while there was real concern. But thankfully, years of tracking have shown it will safely miss us. So the fear has faded, and what's left is a once-in-a-lifetime scientific opportunity. This flyby is essentially a live rehearsal for planetary defense. It's a chance to test our ability to track and predict the path of a near-Earth object with incredible precision. But it's more than just a tracking exercise. As Apophis zips past, Earth's gravity will tug on it, creating tides not of water but of rock and dust on its surface. Scientists expect to see real-time changes, landslides, loose rubble getting shaken up, and maybe even a slight change in the asteroid's shape. We've never been able to observe these tidal effects up close on an asteroid this size before. It's a natural experiment you could never replicate in a lab. To capture every detail, NASA has sent the OSIRIS-APEX spacecraft to rendezvous with Apophis right after its close approach. Its mission is to document every new scar and rearranged boulder, giving us invaluable before and after pictures. This will show us exactly how asteroids respond to gravitational nudges, critical information if we ever need to deflect one. For the scientists and engineers working on this, it's a full-circle moment. Some of them, like Andrea Riley on the DART team, remember being teenagers worried about Apophis. Now, they're the ones helping turn a story of fear into one of preparedness and discovery. Finally, let's journey to an interstellar visitor that's breaking all the rules. Comet 3I Atlas. From its very first spectrum, astronomers knew this one was special. Its path showed it came from outside our solar system, but it was the comet's chemical fingerprint that really got people excited. Early data revealed its coma wasn't dominated by water vapor, which is the norm for comets. Instead, it was spewing out enormous amounts of carbon dioxide. The James Webb Space Telescope confirmed it. Atlas was releasing nearly 20 times more carbon dioxide than water. In our solar system, that ratio is usually flipped. This comet was playing by a completely different set of rules. And the weirdness didn't stop there. Spectra also picked up a strong signal of atomic nickel streaming from the coma. But its usual companion, iron, was completely missing. In our comets, nickel and iron almost always appear together. The absence of iron in Atlas is a huge puzzle. Did it form in a completely unique environment? Did the iron get stripped away during its long journey between the stars? Theories are flying, but no single model fits all the data yet. Then, in mid-August, another surprise. A sudden outburst doubled the comet's brightness in less than 2 days, causing its tail to split. These eruptions don't seem to be driven by water, but by pockets of other volatile gases like carbon dioxide. To make things even more complex, the comet appears to be a slow, tumbling spinner, making its behavior incredibly hard to predict. With every new piece of data, Comet 3I Atlas becomes more intriguing. It's a chemical outlier, a messenger from a distant, unknown part of our galaxy, and astronomers are racing to learn all they can before it vanishes back into the darkness. These 3 cosmic stories show us just how dynamic and surprising our universe can be. From a fragile comet lighting up our skies to a planetary defense drill, we're constantly learning more about our place in the cosmos. Thanks for watching. If you enjoyed this journey through space, don't forget to hit that like button and subscribe for more amazing stories from our universe.